Okay, in this video for my MAE 3323 Mechanical Design 1 class for the fall semester of 2012, I want to show just a little bit of MathCad used to solve sets of nonlinear equations, and then show that how that might be used to solve an interesting statics problem similar to one that you have for homework, and could be useful for the rest of the semester. As part of some MathCad training, let me point out that on the online classroom site under Contents, I've created a module called Learning MathCad, and it has a MathCad file that's in a zip file that you could print out. And then I made a video a few semesters ago for the teaching assistants in the Design CAD class, who were going to train students to use this first MathCad type this file for homework. So I would suggest you print this one out, you watch this video with this printout in front of you, and then you maybe even go attempt to type in this MathCad type this file to learn a little bit of MathCad. Okay, assuming that you already know a little bit of MathCad and you've already typed the give and find block as done in that first MathCad file, I want to look at applying the give and find block just a little more to a few different problems. And so a give and find block is the word given typed. Just click somewhere and type G-I-V-E-N, and then don't type a space, don't type anything else, just click away. That begins a given and find pair. Matter of fact, these two givens are now interacting badly, so I'm going to get rid of that one, and I have a given find pair. In between the given and the find, we need to have as many equations as we want to solve, so that we have an n equation n unknown set. Since I only have one equation between given and find, and notice this thing has a bold equal sign next to it, which is typed by holding down Control and hitting the equals key, so I call it a control equals sign. And so make sure your equations inside of here that you want to solve will have a control equal sign in it. In addition, since this thing assumes all equations are nonlinear, and in general nonlinear solvers need guesses to get the answers, we're going to make a guess. It's a pretty crummy guess for the value of x, and we're going to see which one it leads us to. Okay, and then we say later on, find parenthesis x, the unknown, in the equations to be solved for. And this is a colon equal sign. It may be a little bit hard to see on the screen. I'm sorry, this is a printing equal sign. It's not a colon equal sign. Just hit the plain old equals here, and it prints out the value of 0.303. Now what I've done was to take this equation and plot it. And we can see it's a cubic. And this cubic does cross the axis 3 times. And starting from a guess of 0, I'm not surprised that it moves over to the minus 0.303 solution. Starting from a guess of about 0.7, I would expect it to go to the solution near 1, which appears to be exactly at 1. If we started from a guess of 2, I would expect it to head toward the solution of 1, and it does. But if we did a guess of 3, I would expect it to head to the answer that's in the neighborhood of 3. I think you can see this cursor. If not, I'm pointing to the solution near 3. This is one equation, one unknown. To expand it to 2 equations, 2 unknowns, I change the equation to the equation of a circle of radius 6. And then an equation of a straight line, y equal 3x plus 5. And then this is now 2 equations, which means I have to solve for both x and y, 2 unknowns, and I've got to give them each a guess. If I make a guess at x equals 6, y equals 0, first of all I can see the circle of radius 6. Here's my straight line. Guessing x equals 6 has led me to x equal 0.3 and y equal very, very close to 6. Okay, and so that would be an upper solution. If I were to change my guess here to a minus 6, I would expect the answer to change to a minus 0.333 and a minus 4.99. We can't see that one on the screen, but I think we can imagine this straight line intersecting the circle in the lower half. And so this is a 2 equation, 2 unknown problem. Now how could you use this in your homework? First of all, you have a cubic equation that can be used to solve for the principal stresses in a full 3D Mohr circle problem. One way you could solve that cubic of that polynomial, many of you can do that in your calculator, but certainly a MathCad given find block would solve that one equation, one unknown problem. Then the other way you could put this to work is, and I'm going to go steal a picture out of the homework document and paste it. This should look familiar to you. I'm going to make it a little bit smaller, just have a little bit more room on the screen. And let's just sort of drag it out of the way. Okay, it shows you that you can easily paste pictures into MathCad. And for homework, you've got to solve this problem. And so I thought I might solve this problem using a MathCad given find block. And so now here's what is not great about the video system I'm using right now, and that is I don't have a great way like to do sketches and draw Freebody diagrams right now. And so what we're going to do is imagine a Freebody diagram. So I'm going to solve this problem. I want you to imagine, first of all, let's do a little bit of quick counting. Got two main bodies, two bodies in this problem. For each of these bodies in a planar situation, which it is, I can write three equations of statics. Sum of forces in the x equals 0, sum of forces in the y direction on the body equals 0, and sum of moments about any point I like is equal to 0. So I can write three equations for this body and three equations for this body. That should lead me to 6 equations and therefore 6 unknowns to be solved for. Where are my 6 unknowns? I've got an x and y force in this pin joint, an xy force in this pin joint, and an xy force in that pin joint. And that's a total of 6 unknowns for my 6 equations. Looks very solvable. Saying the same kind of thing for this problem, I've got 3 bodies, 1, 2, 3, and which means I can write 9 equations, 3 bodies, 3 equations each, 9 total equations. I would expect to have 9 unknowns, and every pin joint except one in this problem is going to have 2 unknowns. 1, 2, 3. Those 4 pin joints will each have 2 unknowns. That's 8 unknowns. But this pin joint's only going to have 1 unknown. There is no force in the horizontal direction, but there is a force in the vertical direction. That would be my 9th unknown. And so 9 equations, 9 unknowns. These equations of statics can be written for this problem and solve for the unknowns. Now, we could take advantage in this problem of the fact that this is a 2-force member, which means the force passing through this member is axial tension only, and the force must align with the body itself. So what I could do is write 6 equations. The equation for this one, the equation for this one, and then I could place a force right here which is horizontal, magnitude unknown. I could place a force right here that is horizontal in the opposite direction, magnitude unknown, and make that a replacement for this link. And then the unknowns that I would have then would be 1, 2, 3, 4, a 5th one for this unknown force, and a 5th one for the 6th one for the vertical force here, and summing moments and summing forces on these 2 bodies only would give me 6 equations for 6 unknowns. All right, so let's go to work on this one and we'll just do it in the most general way and assume nothing. I'm going to say given, and I'm going to imagine a Freebody diagram of this body only, and at point O I'm going to have an x force and a y force, and I'm going to assume that they're both in the positive direction at the bottom, and at point B I have a force of the pin joint acting on this body, and I'm going to assume that this load right here shown at B of 0.8 kilonewtons applies to this body, not that body. So I'm going to make that assumption. So summing forces in the x direction on that vertical beam is FOX plus FBX control equals 0. And in the y direction it would be FOY plus FBY control equals 0. And then I'm going to sum moments for this body from the free body that I have in my head. And the only thing that's going to cause moments of this body, neither of forces down here will cause moments about 0.0, and only the horizontal force will cause moment about 0.0. So I'm going to say FBX times 0.9, and if XBX, let's see, if FBX is in the positive direction, it would cause a right-hand rule negative moment. So just to be careful, I'm going to go ahead and do that. And I'm going to put a minus in front of that. And then I'm going to say control equal 0, which means the sign discussion was moot. Okay, the only force that can cause a moment acting on this free body, because this force does not belong to this body. Okay, the only force that can cause a moment that doesn't pass through 0.0 is this one. Okay, and what that says, of course, is FBX is 0. But we don't have to know that. We don't have to predict that in advance. Now what I want to do is look at the free body diagram for this link, and I'm going to assume down here at point A that the forces are positive, but up here at point B, I'm going to assume that those forces are in the negative direction to make it equal and opposite to the forces that were being applied on this body. And in addition, I will include the 0.8 kilonewtons. And so I would say that FAX minus FBX, and then minus 0.8 kilonewtons, because it's in the negative direction, control equals 0. That's sum of forces in the X. Sum of forces in the Y would be FAY minus FBY, control equals 0, because this force has no Y component to it. And then I'm going to sum moments about point A and the X force and the F force, both pointing in the negative direction, will contribute a moment. The Y force at point B will contribute a moment through this distance, and I need to calculate that horizontal distance between O and A. So let me just pause and jump off to the side and say H distance colon equal to, and this distance is related to this distance through the 60, and so let's see, so opposite over adjacent 0.9 over this number is equal to the tangent of 60 degrees. So I just need to type that out to see it. 0.9 divided by, 0.9 divided by H distance, control equal to the tangent of 60 degrees. Now, just a little trick, sort of a waste in this problem. If I click on H distance and go to, and you can't see this, I'm going to pull the menu down for a second and say symbolics, variable, solve. It cranks through and says H distance therefore must equal 0.9 over the tangent of 60 degrees. And so I'm just going to go ahead and steal that. Of course I could have done that myself. Paste that in, and now I'll delete these two. Don't need them. And I'll just keep that handy, maybe right there. Let's get the menus and stuff back out of the way. I don't really need those. Okay, and so now I can write my moment equation, and it's the sum of moments about point A, and it's going to say minus FBY, because it is, I'm assuming it's pointing in the negative direction on this body, times h distance, then minus parenthesis FBX is pointing in the negative direction, then plus 0.8 is pointing in the same direction as FBX, times 0.9 distance, control equals 0. Now I think I do want to stick with the right hand rule though. So FBY, so counterclockwise would be positive in this direction. So FBY pointing down, in fact, would cause a positive moment. So we'll get rid of that minus. And then FBX going negative, these would also produce a positive moment. So we'll change that sign. Pretty sure I've got it right, so let me think about this again. FBY is negative times that horizontal distance gives a right-hand rule positive moment. FBX being negative and that being negative produces counterclockwise, which is a positive moment. So I'll go with both of those, and then I will say find, and I've got 6 equations, 6 unknowns, which would be FOX, comma FOY, comma FBX, comma FBY, comma FAX, comma FAY, parenthesis, equals, and of course it doesn't give an answer because I don't have guesses. So FOX colon equal to 0 tab, FOY colon equal to 0 tab, FBX colon equal to 0 tab, FBY colon equal to 0 tab, FAX colon equal to 0 tab, FAY colon equal to 0, and I would have hoped for an answer at this point, and so I've typed something wrong somewhere. So let's see if it'll tell me what it thinks is undefined. I'm going to right click. I'm going to click there. Right click will usually bring up a menu. Is it bringing it up elsewhere is the question. It is not. Alright, let me just look at it and see what's wrong. FOX, FOY, FBX, FBY, FAX, FAY, FOX, FBY. That would help. FBX, FBX. Okay, now we fixed it. I just had some typos in there, and so let's move this down. I'm going to use cursor keys to move that down. Then let's see if any of this makes sense. Okay, and it says that FOX and FBX are both 0, and that makes sense because this is also a 2-force member, so there must be a force only along the length, and those forces must be equal and opposite, and those would be the Y forces, 1.386, 1.386. Okay, and then on this link, the only horizontal force we have, since there is no pin horizontal force, is the 0.8 reacted by an FAX at 0.8, and then the Y direction force at point A must equal to the Y direction force here. Now let's check some signs. This should be in compression. Yes, in compression. so that FOY should be positive, and the pin joint force on this one should be negative, which means the pin joint force acting up on this one would be positive. Therefore, the pin joint here should have a Y force of negative to place that one in tension. It does. All of this looks like it makes sense. And so all I've done is write the equations of statics for this structure, 6 equations, 6 unknowns, fix my typos, do a little bit of trig, and solve for the answer. Take a look, as I said, at the MathCad Type This and learn a little bit more MathCad if you want to.